Okay, page 341, 51, 1 through 14. We kind of remember the last 8 problems we did yesterday?
Yeah.
Oh yeah. Oh, this is fun stuff.
All the stuff that I'm erasing right now.
We're gonna leave that up there. I said, I love how you looked at it and you're like, no, not yours.
Okay.
Invitation to take it out.
That's Jasmine's invitation, I guess. Do you guys remember the exponential growth formula? Or simple interest formula?
A equals plus 1. Well, yeah, inverse.
1 plus.
Oh, 1 plus.
Rate and then time.
Okay.
And then
Compound interest.
I don't remember the T
Plus 1. And then it was like
1 plus.
R
over
K. Yeah.
and then
K T.
Yeah. That's it. Where K is the number of times we're compounding per year.
I don't remember the T in front of the A yesterday. Or the T button.
That's just function notation. This is all one thing. It just says the amount depends on what you put in for T.
Gotcha.
Alright. So, number 1 says for each exponential function, identify the initial amount, the percent change, and the growth factor. The growth factor is the number that you multiply by repeatedly. That's what factor means. It's basically what's in the parentheses simplified. So it's whatever 1 plus the rate is, or it's the number in the parentheses is the growth factor. State whether the function models exponential growth or exponential decay. How do we know if remember yesterday we had some that went up and got steeper and steeper and some that went down?
Mm-hmm.
How do we know if that's going to happen or not?
Well, if it says minus in the parentheses.
Well, maybe. If it says 1 minus 0.02, yes. But basically, if you if the number in here is less than 1, and you multiply by a number less than 1, it's going to go down. If the number in here is bigger than 1, keep multiplying by a number bigger than 1, you're going to get bigger. So, number 1, there's 4 answers. These will go, but it goes pretty quick. Number 1, what is the initial amount? 20. It's just the number up in front there. What is the percent of change? I will write this down.
30%.
Okay, close.
0.03.
No, we're gonna keep it as a percent.
So 3%.
But it's important that it says it's minus 3/10 instead of plus 3/10. So we need to indicate, that it's a negative 30%.
Oh, okay.
What is the growth factor? So basically, what's 1 minus 3/10? The thing in parentheses that you multiply. That you're multiplying by is the growth factor, yes. 1 minus 3/10 simplifies to 7/10. Is it going to decay or grow? Decay, because 1 minus 3/10, 7/10 is less than 1, basically. So it is decaying. See? Easy peasy.
The first one.
They're all the same. Kind of. What's the initial amount on number 3?
4.2.
What's the initial amount on number 4?
1.
1. Okay, anyway, 42. Okay, they already simplified the parentheses on number 3, right? So, what is the percent of change?
50%.
Right. It's basically 1 plus 0.5. That's how they got it. And what's 0.5 as a percent? Change a decimal to a percent. You just move it over twice. So anyway, it's What's the growth factor?
0.5.
No,
1.5.
1.5.
Oh, okay.
Is it growing or decaying?
Grow.
1.5 is greater than 1, so it's going to grow.
Gotcha.
Okay, number 5, what's the initial amount?
1/2.
1/2.
50 cents.
What is the percent change on number 5?
50%.
Close.
-50.
Negative 50. Why is it negative? Because it's dropping down from 1 to 1/2, so it's going down 50%. 1 minus 1/2, that's like, 0.5, so anyways, negative 50%.
Yeah, that's not a good number to see on a spreadsheet.
And what's the growth factor?
1/2.
And is that growing or decaying? Because 1/2 is less than 1. What's the initial amount on 7?
$10.
What is the percent of change?
Minus
This is
0.25 or
close.
0.25.
Close. So if I did 1 minus 0.975, do you guys know what I would get?
0.025.
Yeah.
That's what I meant.
Okay, that's how much it's changing by, but we need to change that to a percent.
So move the thing back. So it's 2.5%.
Right. Move it over twice, 2.5%. And is it going up 2.5% or down 2.5%?
Going down.
Down. It went from 1 to 0.975. So that's going down. So it's negative 2.5%. What's the growth factor?
975.
Is it a growth or decay?
Decay.
Decay.
I think this is too high.
Number 9. Write an exponential function modeling each situation and state whether the function models exponential growth or decay. Then evaluate f of 5, f of 12 for each function. So I guess our functions are going to be called f of t. Okay, $33,000 car is expected to lose 1/6 of its value every year.
That's not good.
So I'm going to start all these with f of t. What's the 33,000?
That's the initial amount.
Initial amount, so it just goes up front. So it says it's going to lose 1/6.
5.
So it's like, so in the parentheses, it's like 1 minus 1/6. So it's only going to be 5/6 of what it was. I'm just going to put the 5/6 version, simplify it like most of the other problems. And then what?
And then the time.
T. Okay. T can be a lot of things, but they tell us in the direction. Oh, actually, they tell us a couple things. Is this going to be a growth or decay?
Decay.
Cars, right as you drive them off the lot, they can start losing value, right? But anyway, that's a decay. And then it says find f of something.
It's f of 5 and f of
5 and 12. What does f of 5 mean on this problem?
5.
5 years for T.
It means what's the value of the car after 5 years?
Yeah.
So just plug a 5 in right there on your calculator and hit equals. Since we're talking about money, what do we need to do probably?
Put dollar sign.
Round it to the nearest cent usually.
But you also got to put dollar sign to this one.
Unless you're doing taxes. On taxes they round it to the nearest dollar.
Well, good for them. I bet you that you always have to round up.
No, I don't think so. Gross. I'm not looking at the trash can. Somebody have scrambled eggs? Nobody's gonna climb it.
It wasn't me. I'm not gonna tell you what it is. I want to ask somebody to do that.
Everybody should be plugging this in. Make sure you're doing it right. Number 9 was $13,261.96, and then you need to find f of 12. So usually, a lot of calculators have a function where you can just hit the up arrow and maybe hit enter or something, and then just go back and change the number that you put in for T.
Oh, that's really. Is that a normal rate of decay for your car?
Let's see. After 12 years, the car might be ready. Well, just depends. Might be close to retirement, so that's. That seems a little bit too steep, but it's pretty close.
If you're gonna grow by 6%, in the parentheses, would it be 1.06?
Yes.
I love this stuff.
Of course, if you're a vehicle owned by my grandpa, you could expect a 50-year life cycle. 9.
I feel like it's all on the same one.
All right, number 11. A telecommunications company plans to expand its workforce of 220 employees by 3% a year. So 220 is the initial amount. It's going up 3%. So what do I put in parentheses?
1.3.
1.03. And then, is that growing or decaying?
Is it 1.3 or 1.03?
1.03.
Oh
0.3.
yeah, that's right. That would
0.3 is actually 30%. 0.03 is only 3%. And then you got to find out what f of 5 was and f of 12.
That's a lot. You want us to round down?
Yeah, you got to write the answer down. Yes.
No, I said, do you want us to round down?
Oh, round down. Round to the nearest cent. Not down.
Oh, we're talking about employees here.
Oh, that's
Are
right.
you chopping it?
Yeah.
Chopping it now. Yeah, they probably rounded to the nearest person, I guess. Yeah, they did. Half a person.
Actually, just like cuts off 0.6%. Sorry, we're gonna need your finger real quick.
You're getting laid off, but before you do.
No, they just get like a cat or something. It's like, they don't count you, but like, it could just work. Like 1/6 of the time.
Or they could be racist and say you're about 2/3. You guys know where I got that from?
Yeah.
Yes.
I think that's something you learn in history.
Yeah. Do you know what year?
Gotta remember that.
You know what year that was passed? passed in the
How would you put 1/3
in the
of
Constitution, wouldn't it?
decay by 1/3?
It'd be what's 1 minus 1/3.
3. Yeah, compromise. So one I said
If you have
was-
one cookie and
yeah,
you
it
eat
was
1/3
for
of a
Constitution
cookie.
Because they were arguing over how many delegates you got.
Okay, number 13. All right, did you guys plug the numbers in for 11? Should have been 255 and 314. Okay, number 13. The amount of 50 grams of an isotope remaining after m minutes if its half-life is 8 minutes. Oh, I forgot about half-life. Half-life means every 8 minutes or it's only going to have half as much as it was. I forgot how to do these actually. Snuck this one in on me.
Let's just
A times 1/2 to T over H.
Yeah, there it is up top.
No, I just knew that.
Yeah. Good job, Matthew. Is that the only half-life one? Yes, it is.
Why do we need to know about radioactive decay? I'm sorry, but
In case you want to measure isotope.
Well,
Uranium isotope 357.
if you want to figure out how long it is before you can live in a radioactive area, I guess. Something like that. All right, anyways. If you want to be a nuclear scientist. The amount of 50 grams, when I took, okay, 50 is our initial. So I'm using the formula you see up towards the top of the page. That math you remember.
Yeah.
50 grams.
So F of T equals 50. So half-life. So you always put a half in there. And H is the half-life, and it said what it means. How long it before it reaches half of its life? It gets split in half. 8 goes down there. I don't know how to say it. And the n minutes would go up here. N minutes. I suppose I should put F,
So we're plugging 8.
F of n right there.
So we're plugging 5 and 12 in for the minutes.
Yes.
Okay.
Okay, is this going to be growth or decay?
Decay.
Decay. It's going to keep splitting in half every 8 minutes. So what is F of 5 and F of 12?
That looks right. Are we running to decimals here? Or like does that have to be a whole number?
Let's see, 13, they round to the 10th place. First decimal place.
Gotcha. Ain't that just smart?
Ain't that a shame?
I mean, you did.
Okay, so remember after you finish this, make sure and go back and finish yesterday's. I don't know if you guys remember yesterday's. Feels like a long time ago.
A long time ago.
A lot of it was graphing with the -2 to 2. Some of it was
Fun stuff.
compound interest.
Compound interest is fun stuff.
Fun in the sun.